We're going to transition now into some of our probability standards. We're going to start with set theory. A lot of this is vocabulary and different notation. And guys, I promise, pay attention to this because the notation that we're going to talk about today is going to be used in our probability questions moving forward. And so you're going to want to be very familiar with this vocabulary and notations from this lesson. The first blank here, a set is a collection of distinct objects. And then each object in a set is called an element of the set. A set is often denoted writing the elements in braces. Those little curly braces is how we write a set. Use set notation to identify the elements in each set described below. So we're going to set up some examples here, 1, 2, and 3, and then we're going to use them below. So number 1, set A is the set of prime numbers less than 10. So let's list those out. Prime numbers being any number whose multiples are 1 and itself. So 1 does not count. So 2, 3, 5, and 7 would be a list of prime numbers less than 10. A of n of A, there are 4 elements in set A. Let's look at number 2. Set B is a set of even natural numbers less than 10. So evens 2, 4, 6, and 8, less than 10, not including 10. And again, n of B, the number of elements in set B is 4. Number 3, set C is a set of natural numbers less than 10 that are multiples of 4. So 4 and 8. The number of elements in set C, there are 2. Our next vocabulary term is the universal set. Denoted by a capital letter U is the set of all elements under consideration. In our example above, what we've been working with so far with example number 1, 2, and 3, the universal set was all the natural numbers less than 10. You can see that above with number 1, it was prime numbers less than 10. Number 2 was even natural numbers less than 10. And 3 was numbers less than 10 that are multiples of 4. So the universal set, everything that's being considered is any natural number less than 10. So we had 1, 2, 3, 4, 5, 6, 7, 8, and 9. There were 9 values in the universal set. A set with no elements is called the empty set. The notation here, I'm going to emphasize, can be either empty brackets or that 0 slash to show an empty set. Next vocabulary term is the complement. And the notation can be A with a little C, subscript C, or a little tilde A, is the set of all the elements in the universal set that are not in that set. So your complement is everything that you're not looking for. So what is the set A complement? So we're referring back up to the beginning of our notes where we looked at set A and we defined set A as the set of all prime numbers less than 10. So let's list that out again. That was 2, 3, 5, and 7. So A complement is everything else. What is not a prime number less than 10? 1, 4, 6, 8, and 9. So let's illustrate that here. Over to the side, we've got U is representing our universal set over here, and we're going to title this our A set. We've got 2, 3, 5, and 7 that were in set A. Everything else, 1, 4, 6, 8, and 9 is still part of the universal set, but we were considering the complement. So everything out here, I'm going to shade. This was a complement of set A. Our next definition, a set is a subset. And the notation there looks like a sideways C. Of another set is every element in the first set is also an element of the second set. In our example, C is a subset of B. Why? Well, let's list those. So set of C was all the multiples of 4, so 4 and 8. And B was all of our even natural numbers less than 10, 2, 4, 6, and 8. And you can see C is a subset or part of elements of B. So let's make a diagram here. We've got our entire universal set. We're going to have set C is part of B. We've got 4 and 8 in our set of C. In B, we had 2, 4, 6, and 8, and then we still had 1, 3, 5, 7, and 9 in the rest of our universal set. So let's look at some examples like you will have on Delta Math number 4. Given that the universal set U is 1, 5, 9, 11, 12, and the subset B is 1 and 5, what's the complement? Remember, that's the not. So I'm going to use B with a little c for complement. The complement of set B in set U. So 1 and 5 are already being shared. So what's the complement of set B? 9, 11, and 12. Number 5, given the universal set U is 1, 5, 9, 10, 11, subset B is 5, 9, and 10. What's the complement of set B in set U? I'm going to use that other notation, little tilde B, the complement of set B, is going to be they are sharing 5 and they are sharing 9 and 10. So the complement of set B in set U is 4 and 11. All right, so here we are getting into some notation that I need you to memorize because, as I said at the beginning of our notes, we're going to just keep using these notations and I want to make sure you are comfortable with them. This next blank is the intersection. And that notation, notice it looks like a N shape. It's a curved shape, kind of like an N. And so there's your memorization tool. It looks like an N for intersection. So the intersection of two sets is the set of elements that are in both. It's what they share. So what is the set A intersection B? Well, let's list A. A was 2, 3, 5, and 7. Set B was 2, 4, 6, and 8. So what do they share in common? They have a 2 in common, and that's it, right? So let's come over here to our diagram, and we have set A and we have set B looking like a Venn diagram here. Set A and B share that 2. A contains 3, 5, and 7. B contains 4, 6, and 8. And there's still some extra elements in our universal 1 and 9. And we are talking about this intersection, what they share, the 2. So let's see what that's going to look like for you on Delta Math. Number 6, given set A is 1, 2, 3, 7, 8, 9, and set B is 1, 2, 4, 5, 8, 11. What is the intersection of sets A and B? This notation is going to be everywhere. So that's the A with the N shape B, the intersection. What do they share in common? 1, 2, and 8. Notice number 7, given set A is 9, 10, 12, set B is 3, 4, and 6, and they use here that intersection notation. What is A intersection B? You have to be very comfortable with this notation. This is also can be written as A and B like it was in our last problem. So what do they share in common? Nothing, empty set. So on Delta Math, you will just leave it blank. There is nothing in common. There is no intersection. The last one here is union. The union, and notice the notation there looks like AU, of two sets is the set of all elements that are in the first set or the second set. Notice that notation U can help you remember union. Now, I'm going to make a connection here. It's a little awkward, but union, when people get married, it's called a union, right? So when two people get married, now they share everything, right? What was his or hers, it doesn't matter. Now that there is a union, now that they are married, they share everything. And that's what that definition is saying. It's saying whatever was in set A or set B. So everything. So union is everything. What is the set A union B? Let's list them out again. A was 2, 3, 5, and 7. B was 2, 4, 6, and 8. What would be their union? A, union B, they share a 2, 3, 4, 5, 6, 7, 8. They are a union. So now it doesn't matter whose was whose, they share everything. In our diagram here, we're going to list this A and B. And just like we had before, we had that they do share a 2. A still has 3, 5, and 7. B has a 4, 6, and 8. There's still a 1 and a 9 in our universal. But as we go to shade for our union, we're looking at all of it. They are married. So everything that they have together. Number 8, set A is 3, 4, and 7. Set B is 4, 10, 11, 12. What is A union B? Look at that notation. I can also write this as A or B. Use those interchangeably. Get comfortable with those. So everything, 3, 4, 7, 10, 11, and 12. I do want to put them in numerical order. Number 9, set A is 1, 5, 8, 12. B is 4, 5, and 7. What is the union or A union B? Again, I want you to get comfortable with that notation. They have 1, 4, 5, 7, 8, and 12 that they now share together in their union. So this is the beginning of our probability section, laying down some vocabulary, most importantly, our notation, especially for intersection, looks like a N, intersection, and union looks like a U. We are going to be using those quite extensively, interchangeably, over and over the next couple of lessons. So do make an effort to keep those in mind and practice those and make those connections. Practice, 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 intersection and union. Intersection is what they share in common. Union, they share everything. They got married. So now they have everything in common. They share every element. Practice those, guys, and I'll see you in class.